Let's continue with the GMAT problem. So we are on problem 16 on page 279. Problem 16. Is x greater than 1.8? Is x greater than 1.8? That's all they're asking us. And statement 1 says x is greater than 1.7. Well, that doesn't help us because, I don't know, x could be 1.71, in which case this wouldn't be true, or x could be 1,000,000, in which case this is true. So this isn't really that helpful. Immediately see that. Statement number 2 says that x is greater than 1.9. Well, if you're greater than 1.9, you're definitely greater than 1.8. So this is all we need. Statement number 2. So B. Problem 17. Problem 17. If n is an integer, is n plus 1 odd? N plus 1 odd. Well, if n plus 1 is odd, that's the same thing as asking is n even. And I haven't looked at the statements yet, but that's just something your brain might automatically connect. And let's see, what do they tell us? Statement 1 tells us that n plus 2 is even. Well, if n plus 2 is even, then n is definitely even. Then n is even. If you don't believe me, think about the number 4. 4 is even, and 4 plus 2 is 6, which is still even, right? Because if you add 1, you're going to go from even to odd. You add 2, you go back to even, right? So this is all we need. If n plus 2 is even, then we know that n is even, and that n plus 1 is odd. And you could try it out with numbers if you don't believe me. 2, what is statement 2? Where did that number? Oh, n minus 1 is odd. Well, this is the same thing. N minus 1 is odd. Once again, this tells us that n has to be an even number. If you subtract 1 from it and you get an odd number, then it has to be even. If you say that n is 4, 4 minus 1 is 3. And try it for any even number. And you know how, I think it's, I don't want to over-explain what's a fairly simple problem. So anyway, the answer is that either of them alone are sufficient, D. And try it out with numbers if you don't believe me. Problem 18. Problem 18. Is x between 1 and 2? Is essentially what they're saying. And it can't be 1 or 2 because these aren't equal signs. They're just less than signs. Okay, so that's what they're asking. Statement 1 tells us that x is essentially greater than 0. They wrote it a little different. They said 0 is less than x. So x is greater than 0. That doesn't help us. X could still be 0.1. It could still be 1/2. So that doesn't tell us where it is in this range. And then the next, and it could also be 100, in which case it's out of this range. Statement 2 tells us that x is less than 3. X is less than 3. So this alone doesn't help us. X could still be 2.1, or x could still be minus 1,000,000. This doesn't help us. And even if we took them together, that would just tell us that 0 is less than x, which is less than 3, which is a superset of this, right? If we know that x is in this range, it doesn't tell us that x is definitely in this range. For example, if we know this is true, x could still be equal to 1/2, but 1/2 isn't in this range. X could be equal to 1.5, which is in the range, or x could be equal to 2.5, which isn't in the range. So both of these, even taken together, are not sufficient. So the answer is E. Problem 19. These are going fast, maybe too fast. Let me know if I'm going through them too fast. Okay, water is pumped into a partially filled tank at a constant rate through an inlet pipe. At the same time, water is pumped out of the tank at a constant rate through an outlet pipe. Okay, so essentially we have a tank. Some water is, there's a pipe here. So water is going in at, x, we could say, I don't know, meters cubed per second, or meters, the units shouldn't matter. And it's getting pumped out at y, I don't know, meters cubed per second. At what rate in gallons per minute? Okay, so these aren't meters cubed per second, these are gallons per minute. And these are gallons per minute. At what rate in gallons per minute is the amount of water in the tank increasing? So in order for the water to be increasing, more has to be coming in than going out. And the rate of it is going to be the difference. So essentially, they just want to know what x minus y gallons per minute are. If x is less than y, and we get a negative number here, then actually we have more coming out than going in, and so the water isn't increasing. So anyway, they tell us that 1, the amount of water initially in the tank is 200 gallons. That's useless. Why is that useless? Because that just tells us how much water is in the tank. It doesn't tell us anything about the rates going in or out. So that's useless. 2, water is pumped into the tank at a rate of 10 gallons per minute. So x is equal to 10 gallons per minute. Right? That's the rate you're pumping into it. And out of the tank at a rate of 10 gallons every 2.5 minutes. So y is equal to 10 gallons per 2.5 minutes, which is equal to what? That's 4 gallons per minute. So that second statement was a little bit, that second part of statement 2 is a little bit shady, but you get a y. It's 4 gallons per minute. And so you actually don't have to figure it out, but if you wanted to, you could say that the rate at which water is increasing is the rate at which it's coming in at 10 minus the rate it's going out. So it's 6 gallons per minute is actually the answer to the question. But all you have to know is that you just needed statement 2, which gave us this information to figure it out. And statement 1 was useless. So that's B. Statement 2 alone is sufficient. Let's do another one. Okay. So we have problem number 20. Problem number 20. Is x negative? X negative? Negative number. Okay, the first statement, they tell us that 9x is greater than 10x. So this is an interesting situation. So let's try to solve this equation. Let's subtract 10x from both sides of this equation. And if you're adding or subtracting on both sides of an equation inequality, the inequality stays the same. So let's subtract 10x from both sides of this. So you get 9x minus 10x is greater than 10x minus 10x. And then you get minus x is greater than 0. Or you could multiply both sides by -1, you get x. And when you multiply or divide by a negative number with an inequality, you switch the inequality. X is less than 0. So we know that x is definitely negative. The other way you could have done, you could have subtracted 9x from both sides, and you'd have gotten 0 is greater than x, which is a faster way of doing it. But either way, statement 1 lets us know that x is definitely negative. Let's see what statement 2 does for us. Statement 2. X plus 3 is positive. X plus 3 is positive. Well, I mean, x could be 100. If x is 100, then 103 is definitely positive. Or x could be -1, right? Because -1 plus 3 is positive 2. So this doesn't tell us any information about whether x is negative. So this is useless. So the answer is A. Statement 1 alone is sufficient. Statement 2 alone is useless. Let's see, how much time do I have? Oh, I'm doing well on time. Which clear. I'm on problem 21. 21. Does 2m minus 3n equal 0? Equals 0. And then the first, and let's just think about this. They're also asking, that's the same thing as asking, does 2m equal 3n if you just add 3n to both sides? These are equivalent questions. So if you can answer one, you can answer the other. So statement 1 says m does not equal 0. Well, that seems fairly useless to me. I mean, m does not equal 0, so m is still, I could pick a random n not equal to 0, and I'd get different, depending on what n is, this may or may not be true. So far, that seems kind of useless for me, but maybe it's useful in conjunction with 2. The next thing they say is 6m is equal to 9n. 6m, oh, this one's interesting, is equal to 9n. So what does this tell us? So 6m is equal to 9n. So let's divide both sides by 3, we get 2m is equal to 3n. And then we can subtract 3n from both sides, and you get 2m minus 3n is equal to 0. So statement 2 I mean, you essentially just do a little bit of algebra and you get what we're trying to prove. So statement 2 is good. Statement 1, do we need it at all? Well, no, because, I mean, that is kind of one solution, that if m and n are both equal to 0, that this thing is true, but it doesn't really do as much in the way of anything else, and we don't need it to come up with this. So the answer is B. Statement 2 alone is sufficient. And I'm already past the 10 minutes. So that's it. I'll do 22 in the next video. See you soon.